Did you know that every year, the world dumps over 20 million tons of trash into the ocean, and nearly 80% of it is plastic? That's the equivalent of 2 truckloads of plastic waste being dumped into the sea every minute. These plastics drift across currents, form massive floating garbage patches, and up to 90% sink to the ocean floor, turning our seabeds into hidden landfills and destroying over 60% of marine ecosystems. Faced with this overwhelming crisis, many nations gave up. But a group of American engineers found a way to tackle the impossible, using a surprisingly simple concept: let the ocean help clean itself. They developed a smart collection system, System 03, that allows plastic waste in the ocean to drift naturally into large collection zones, powered by nothing but the force of ocean currents. But here's the real question: how does such a massive machine operate in the harsh conditions of the open sea? How can something so simple scale up to solve a global disaster? Let's explore the secrets behind it with Massive Minds. International environmental organizations have issued stark warnings. There are currently between 75 and 199 million tons of plastic waste in the ocean, with an additional 11 to 15 million tons entering the sea annually, the equivalent of 2 truckloads every minute, relentlessly. But here's the hidden danger: 99.99% of that plastic doesn't float. It sinks to the ocean floor, where it slowly breaks down into microplastics, entering the food chain, poisoning marine life, and ultimately returning to our bodies. Microplastics have been found in human blood, placentas, and even the air we breathe. We've seen images of turtles trapped in fishing nets, squid and crabs living in discarded plastic bottles, fish sheltering in plastic bags. These are not just environmental tragedies, they are a call to action. After years of research, a solution has emerged: the circular economy. Instead of burning or burying plastic, we recycle, reuse, and return it to the industrial chain. This approach to recycling ocean plastic waste not only helps clean up the environment, but also reduces reliance on raw materials. But recycling is only part of the solution. While it helps us process what has been collected, the bigger question remains: where does all the plastic waste in the ocean go? This is not a national problem, it is a global problem. To address this problem, international technical and environmental groups have set an ambitious goal: to reduce the amount of plastic waste floating in the ocean by at least 90% by 2040. This means scaling up effective ocean waste collection systems, innovating recovery methods, and pushing the boundaries of ocean plastic waste recycling. Not just a concept, but a global industrial movement. Of course, turning that vision into reality is anything but simple. The first and arguably most difficult challenge is this: how do you collect trash in the middle of the ocean? Strong waves, high winds, constantly shifting currents. All of these render traditional cleanup methods useless. You can't use fishing nets, you can't rely on manual boats. So how can we possibly collect ocean trash across an area of millions of square kilometers? Because plastic doesn't stay in place, the environment is unpredictable, and humans can't drift endlessly across the sea for decades. That's when engineers realized, instead of fighting the ocean, we could work with it. By harnessing ocean currents to gather debris naturally, environmental engineers designed a self-operating cleanup mechanism, System 03. With 2 floating arms forming a giant U-shape, System 03 acts like a massive curtain drifting along ocean currents. It features a floating barrier over 2.2 kilometers long, towed by 2 vessels, and a submerged skirt that reaches 4 meters below the surface, the sweet spot where most plastic waste in the ocean is suspended. The process is intuitive, yet astonishingly effective. As System 03 slowly moves through polluted zones, wind and current naturally push plastic debris into the interior of the U-shaped barrier. The ocean's own flow directs the plastic into a retention zone at the back. No fuel, no pumps, just nature doing the work. Once full, the retention bag is hoisted onto the support vessel, where waste is sorted and shipped to shore. Then, the system is redeployed for the next cycle. What makes System 03 truly revolutionary isn't just its scale. It's the AI-powered navigation system, which steers the operation toward the highest density trash zones, maximizing efficiency with every mission. Capable of cleaning an area the size of a football field every few seconds, System 03 operates 24/7 without fossil fuels, relying solely on ocean drift and solar energy. By mid-2025, this system had already removed over 30,000 tons of plastic from the Great Pacific Garbage Patch, one of the most polluted areas on Earth and a key battleground in the global movement for ocean plastic recycling. But cleaning the ocean is only skimming the surface. The real threat lies upstream. Over 80% of plastic waste in the ocean originates from rivers, where cities, neighborhoods, and dump sites continuously push millions of tons of plastic into the sea. Raising awareness is one thing. Changing behavior takes time. So a new strategy emerged: turn off the tap. Instead of just cleaning the ocean, stop the plastic before it ever gets there. This is where the interceptor comes in, an autonomous, solar-powered system designed to intercept floating trash directly on rivers. It uses a floating boom to guide trash into its onboard intake. From there, a conveyor belt system automatically lifts debris out of the water and into onboard containers. Each interceptor can store up to 50 cubic meters, about 1 ton of plastic per day, and runs continuously, day and night, without disrupting boat traffic or harming marine life. From a simple design to surprisingly powerful results, the interceptor has become the first line of defense against riverborne plastic pollution. Once the trash is collected, whether from offshore cleanup systems or river-based interceptors, it is transported back to land for further processing. Specialized skimmer vessels, typically around 25 to 30 feet in length, are deployed to retrieve the waste. In just one 8-hour shift, a single vessel can collect up to 5 tons of ocean trash. These vessels are equipped with hydraulic conveyor belts that help offload the debris directly onto docks or into primary sorting facilities. At the facility, the pre-sorting process begins immediately. Workers first remove hazardous items manually, including tangled fishing nets, discarded tires, and old oil containers, to prevent damage to the machines used in later stages. Once these larger obstacles are cleared, the remaining waste enters a massive rotating cylinder known as a trommel drum. This machine spins continuously to separate recyclable plastic from sand, seaweed, shells, and other natural marine debris. After the mechanical separation, a team of workers carries out a second manual inspection. Here, the collected materials are divided into 3 key groups based on their composition: plastics suitable for recycling, metals that can be reused, and organic matter such as driftwood or biodegradable waste. The clean, sorted plastic fraction is then ready to move into the next stage, where it undergoes deep cleaning and refinement as part of the larger process of how ocean plastic is recycled into valuable, recycled ocean plastic for manufacturing and industrial applications. Even after being collected and sorted, plastic waste cannot be recycled immediately. What is retrieved from the sea is not clean bottles or intact containers, but fragmented debris coated with crude oil, algae, and salt sludge after months of drifting as plastic waste in the ocean. If not treated properly, all of it would become defective material or even damage the entire recycling production line. At this stage, the plastic must undergo deep cleaning and decontamination to transform dirty ocean trash into clean industrial-grade feedstock. This is a critical step in how ocean plastic is recycled, where contaminated waste is converted into usable, recycled ocean plastic. But how can tons of plastic be cleaned every day without destroying its material structure? This is a semi-degraded phase of plastic, where improper handling could generate microplastics that directly affect human health. The answer lies in a precisely controlled closed-loop washing system. The process begins with mechanical washing tanks. Inside these tanks, powerful vortex currents are generated by large industrial paddles. Combined with water friction, these currents strip away layers of oil, salt, and biological residue tightly bonded to the plastic surface. Because the plastic has already been weakened by long-term exposure to the marine environment, the turbulence must be calibrated with extreme precision, strong enough to clean, but not strong enough to damage the material structure. Immediately afterward, the plastic waste is transferred into thermal washing tanks, where water temperature is maintained between 160 and 180 degrees Fahrenheit. High heat softens remaining contaminants, while neutralizing agents are added to the water to remove salt and balance acidity caused by decomposed organic compounds. This step plays a crucial role in restoring the chemical stability of plastics before they move further into the ocean plastic recycling process. Next, all materials enter density-based separation using the float-sink principle. In a massive water tank, heavier plastics like PET automatically sink to the bottom, while lighter plastics such as HDPE and PP float to the surface. Separating plastics based on physical properties significantly improves output quality for downstream recycling stages. Once separation is complete, the materials proceed to drying. Centrifugal drying systems use hot air to remove all remaining moisture. However, moisture is not the only challenge, odor is. Plastics that have drifted through the ocean carry organic compounds that produce fishy, oily, or decaying smells. To fully eliminate this, ozone deodorization is applied immediately after drying. With its strong oxidation capability, ozone breaks down odor-causing molecules and destroys remaining bacteria, transforming contaminated waste into clean, dry, odor-free plastic. This entire process does not take long, but it demands constant precision and strict monitoring. If even a small portion of plastic in a batch is not cleaned thoroughly, it can compromise the entire industrial recycling run that follows. This stage is the true turning point, determining whether ocean trash is genuinely reborn as recycled ocean plastic or merely relocated from the sea to an industrial landfill. The end of this process creates a potential material, a stream of mixed plastics with varying compositions and recycling values. This is why modern facilities in the ocean plastic recycling chain must enter a second refining stage, where high-tech systems operate with near-perfect precision. The current goal is to separate the highest value plastics, especially PET and HDPE, which are widely favored by industrial manufacturers due to their durability, recyclability, and compliance with food packaging or technical component standards. The plastics are fed into a series of deep filtration systems. First is an industrial magnet, used to remove any remaining metallic contaminants, such as aluminum seals, cap rings, or foil fragments. Next, a high-speed swirling airstream removes any remaining bottle labels and caps. Because labels are often made from different types of plastic, any remaining material can affect the purity and consistency of recycled ocean plastic products. Precision at every stage is critical. Any impurities left behind here will be amplified in the subsequent extrusion and melting stages, potentially forcing the entire batch to be discarded. Once the material reaches an acceptable purity, it is passed through a high-speed grinder. Under blades rotating at thousands of revolutions per minute, the plastic is ground into uniformly sized pieces. This piece shape is not random. It significantly increases the surface area compared to bulk plastic, reducing energy consumption by up to 40% during the thermal melting process. This step marks a crucial point in how ocean plastic can be recycled efficiently on a large scale. In industrial environments, energy saving is not just a cost issue. It's essential for operating sustainable recycling plants, especially in the context of global low-emission targets. The grinding chamber is designed to maintain thermal stability, protect the polymer structure, and prevent premature softening due to localized overheating. Even after cleaning, grinding, and drying, recycled plastics are not yet ready for conversion. One final hurdle remains: microscopic impurities within the same plastic. Small variations in color, transparency, or light reflectivity, invisible to the naked eye, can affect the quality of the final product. This is where artificial intelligence comes into play. Using hyperspectral cameras, the system scans each tiny piece, analyzing transparency, reflectivity, and surface color. Upon detecting contaminants, high-speed airstreams immediately target and remove the faulty piece from the line. With over 95% accuracy, these AI-powered systems can process up to 1,000 pieces per second, identifying even the smallest deviations and ensuring that only the purest pieces proceed to the final conversion stage. After being sorted and ground into small flakes, recycled ocean plastic enters its most crucial phase: transformation into standardized industrial raw material. The process begins with melting and vacuum degassing extrusion. The plastic flakes are fed into a sealed heating chamber at approximately 520 degrees Fahrenheit. Inside, a multi-stage vacuum system removes all residual moisture, air bubbles, and contaminants, leaving only a stream of pure, molten plastic with stable viscosity. Immediately after, the molten plastic undergoes underwater pelletizing. High-pressure cold water rapidly cools and shapes the plastic into perfectly round pellets, free of cracks, voids, or trapped gases, meeting global industrial standards for raw plastic. All pellets are subject to rigorous quality control. Rapid cooling is followed by industrial camera inspection to verify size and clarity, tensile strength testing, and chemical composition analysis. Each production batch is tagged with a QR code that enables full traceability, from ocean coordinates to recycling plant origin. Finally comes the product formation stage. Using injection molding and blow molding technology, the plastic pellets are shaped into bottles, jars, or preforms at a speed of thousands of units per second with near zero defects. This is how ocean plastic is recycled into reliable, scalable materials that power modern manufacturing. From plastic waste in the ocean to clean, precise components, this process embodies the essence of ocean plastic recycling, not just removing plastic from water, but elevating it into a valuable resource once again. The final result is a full lineup of finished goods, from food packaging to industrial components, all made from materials that were once plastic waste in the ocean. In the electric vehicle industry, recycled ocean plastic is now being used to manufacture door panels, floor mats, and seat frames for models like the Kia EV6 and Volvo EX30. This material is not only lightweight but also durable, helping to reduce overall vehicle weight and lower CO2 emissions. The fashion world is also undergoing a major transformation. Brands like Adidas and Parley have turned ocean plastic waste into ultra-fine polyester yarns, producing sneakers, swimwear, and backpacks directly from recycled plastic products, with each pair of shoes containing up to 11 bottles that once floated at sea. Even the furniture and construction industries are evolving. Recycled plastic is molded into sustainable chairs, tables, and eco-bricks, up to 30% lighter than conventional concrete, while maintaining impressive load-bearing strength. What's even more revolutionary is the transparency. Each product now comes with a QR code or blockchain ID. By simply scanning the code, users can trace the origin of the item, from a polluted marine zone to the ocean plastic recycling facility, and finally to the finished product. This rebirth is more than just an environmental solution. It's the foundation of a new economy where technology transforms waste into a resource and pollution into real-world value. This is the full circle of how ocean plastic is recycled, not just cleaned but fully reintegrated into everyday life. After a long journey from the seafloor to the industrial production line, recycled ocean plastic, once deemed worthless, has now reached the quality of a premium-grade material. From computer casings and automotive components to food-grade packaging, those scattered pieces of marine debris have become essential parts of the recycled plastic supply chain powering today's global economy. More than just generating material value, this ocean plastic recycling strategy has created thousands of green jobs across coastal nations, many of which were previously overwhelmed by plastic waste. At the same time, it has compelled major corporations like Coca-Cola, Kia, and Adidas to shift from a consumption-driven mindset to a sustainable plastic solutions model based on regeneration. Perhaps this is the clearest sign yet. We no longer have to choose between development and survival. With enough determination and creativity, both can advance, side by side. What about you? What do you think is the next step in the journey to clean up the oceans? Let us know your thoughts in the comments. And don't forget to subscribe to Massive Minds to discover more breakthrough engineering solutions that are transforming our planet, wave by wave, plastic by plastic, and one ocean at a time.